So I took a look at the graph, and this is the correct result. We get negative infinity from this side. Okay, so the graph's going to look something like this. So there's our vertical asymptote. Okay, it's going to go down this way. So this area is negative infinity. Okay, it's below the x-axis. So that's correct. That's this area here. Okay, and this area here on this side is going to be from those bounds, right? I think it was -1 or 1 to 3. Okay, so this area here is unbounded, and that is also infinite. So that is this area here, okay, this is correct. So normally we couldn't evaluate this, but because of the symmetry of this graph, we can say that the net displacement, or the net area, is going to be equal to 0. And although normally we can't say negative infinity plus infinity is equal to 0, in this case, because of the symmetry of this graph, we can say that those areas cancel out and the net area is 0. Okay? All right, doing this next one here, again, we're going across an asymptote of -1 at x equals -1, so we need to set this up as a limit. So we're going to do this as the limit as a goes to -1, from -2 to -1, 1 over, I'm going to write this as a power, x plus 1 to -1/2 dx plus the limit as, this is coming from the negative side, the limit as a goes to -1 from the positive side. Okay. I'm going to write that as a. We're going to start at -1 and end at +1. Okay, so there's our integral. Our asymptote's at -1, so we have to make sure we integrate up to the asymptote from the correct side. It's from the negative side. Here we're going to start from the positive side of -1 and integrate from that asymptote. Okay, we need the limit because of that asymptote. So anti-differentiating this, I get the limit as a goes to -1 from the negative side. This is going to be x plus 1 to the power 1/2 divided by 1/2, so I'm going to do times 2 from -2 to a, plus the limit as a goes to -1 from the positive side, the same integral, or same antiderivative. Okay, except the bounds in this case are from -1 to 1. Okay, so this function here, we are going to approach this function, so we're going to substitute in. Okay, so I'm going to end up with 2, and I'm going to plug -1 into here from the negative side, so I'm going to end up with a negative, so it's going to be 2, and I'm going to write this as square root negative. Okay, and we cannot square root that negative, so it's going to be -0 minus the square root of -2, plugging that in, put brackets in here, -2, so it's going to be square root of -1, okay, plus. Okay, so first we're just going to evaluate this, and it's something that I probably should have thought of before I started integrating this. There is a domain restriction on here, and this we can't do. Okay, so this does not exist. So it's not applicable. So this part here is, we get some really weird results because we're square rooting negative here, we know we can't square root negatives, and the reason why is because when we look at our asymptote here, okay, it looks like that, -1. Oops, so my asymptote's going to be at -1. So it's going to look like that. And we can calculate on this side of -1, but on this side of -1 we were doing, it doesn't exist. Okay, so this part here doesn't exist. So then we can just worry about this side, which I'll start doing in a different color here. So that would be this side of that asymptote, and we can apply that, then we're going to end up with 2. I'm going to plug 1 in from the positive side, so it's going to be 2 square root minus, and then I'm going to plug in a negative 1 from the positive side, so it's going to be square root of positive 0. It's coming from the positive side, so that's okay, nothing wrong with that. And so we're going to end up with this area. The net area is equal to 2 root 2 units squared. Okay? So this part gives us an inconsistent result because we really should have, at the beginning, recognized that this is a domain problem here because we don't have anything on this side of that function. Okay, and I guess that is it for the notes for today.